All right. So as promised, talking about connecting now chemical kinetics, so chapter 3's concepts, or chapter 13, with chapter 14's concept of equilibrium. Okay, so connecting those two pieces of information. So if we have a reaction here, we have reactant A with 2B in equilibrium with AB2. If we looked at our kinetics of this equilibrium, because we are going in the forward and the reverse reaction, we have two different rates that we can talk about, very similarly to what we did with our mechanisms. So for the equilibrium, we'd have a rate constant, or we say K1, that's the forward reaction, and then the rate of the reverse, K to the negative 1. So we have the rate of the forward reaction, lowercase f there for forward, would be K1, our rate constant for the forward reaction, times, we're going to use our two reactants and use the coefficients as our exponents. So we have times the concentration of A times the concentration of B squared. Then the rate of our reverse reaction, so rate, that's a lowercase r for the reverse. We have K to the negative 1 for the reverse reaction rate constant. And we want times our concentration of the reactant for the reverse reaction, so times AB2. So we know that at equilibrium, our definition there is that the rate of the forward reaction is equal to the rate of the reverse reaction. So we have rate forward is equal to rate reverse. So we set these two equations equal to each other. We have K1 times concentration of A times concentration of B squared is equal to K to the negative 1 times the concentration of AB2. What we want to do is we want to kind of get this into an expression that's similar to our equilibrium. So we want to get the concentrations together and the rate constants together. Okay, so rate constants on one side, concentrations on the other. So if I divide both sides by K to the negative 1, that gets the rate constant over on this left side. Divide both sides by concentration of A times B squared. So eliminates it from this side, gets our concentration over here. We end up with K1 over K negative 1 is equal to the concentration of AB2 divided by the concentration of A times concentration of B squared, which if we look at our equilibrium constant expression, we have products over the reactants. So we have product over the reactant. So this is equal to Kc. So what this tells us is our equilibrium constant is equal to our forward rate constant divided by the reverse rate constant.